So let's do some examples. So here we have a rod assembly supported by journal bearings at A, B, and at C. There's a 45 Newton meter moment applied right here, and there's also a 500 Newton force being pulled down on this elbow. We'll assume that the journal bearings are properly aligned. And if that's the case, then what that does is that the force reactions developed by the bearings are sufficient for equilibrium, and they prevent the shaft from rotating about each of the coordinate axes. So no moments are developed. So let's assign this to be our y-axis, x-axis, and our z-axis, and our pipe assembly looks something like this. I'm just idealizing it right there and right there. So that's our pipe assembly. This journal bearing prevents translation of this rod in the z direction and the y direction. Therefore, we'll have those reaction forces at A. So we'll have our AZ, and also there'll be a reaction force AY. There will be no reaction force in the x direction because the journal bearing allows translation in this direction. At B, which is right here, it too prevents translation in the x and the z. Therefore, we'll have reaction forces in those directions. So this will be BZ. At C, that journal bearing prevents translation in the y and also in the x. Therefore, we'll have reaction forces in the y and also in the x. And finally, we can't forget that there were applied moments. So we have to draw that on our final free body diagram. So that'll be 45 Newton meter. And we also have to draw this 500 Newton force there. So that completes the free body diagram for this three-dimensional assembly. Let's do another problem. So here we have a plate. It's supported by a journal bearing where a rod has gone through, and it seems to have also gone through this particular plate. It's supported by a hinge that's attached to a wall, and there's also a smooth round ball there that supports that corner of the table or plate. To draw the free body diagram of this assembly, I'll assign my coordinate system to be as such, where this is my x, this is y, and that's z. That single journal bearing prevents this table from translating in the x and also in the z direction, so we'll have reaction forces in those directions. Let's label this as point A, point B, and point C. So going back, this reaction force would be AX, and also we would have AZ. There's no reaction moment caused by this single journal bearing. That's because we assume that the three supports are sufficient for equilibrium to exist. Therefore, there will be no moment about the x-axis, so it'll be moment about the x-axis right here at A, that's equal to 0. There will be no moment about the z-axis at A, and that's equal to 0. And for the hinge, again, now for the hinge, so that'll be point C. That hinge prevents this table from translating in each of the directions, x, y, z. Therefore, we'll have reaction forces in those directions, Cx, Cy, and Cz. Since we're assuming that these three supports are sufficient for equilibrium to exist, there will be no moment at point C. In other words, moment at C in the z direction is 0. Moment about the y-axis at C is equal to 0. I guess this should be Z and this should be C. And moment about the x-axis at C, that's also equal to 0. So there are no moments